How you doing today?
Good. That was a big day of monitoring.
Oh my gosh, was it ever? Well, I'm excited to do this part. So this is our instructional video for eDNA filtration. I'm super stoked. We've got 3 samples to go through. One is for giant salamander from a creek, and another 2 are for red-legged frog from 2 different lakes. One was Beaver Pond and the other was Greenburn Lake. Really excited to get these filtered. We're going to basically run them through this pump. The water will pull through, the filter's there, it'll catch it, and then we're going to be putting the filters into the coin envelopes, and you're going to be entering the data on the laptop so that the lab has the filtration data ready for it. We do have all of the other equipment just to explain it. This is a gassed pump. Everyone is confused when I say gassed. I don't mean gas. It's G-A-S-T. It's the manufacturer. It's powered by electricity. It runs at 25 psi. It's my pump of choice, but again, I'm not advertising any specific brands. You have to choose your own. But I like this pump because it puts out 25 psi of pressure. And it's pretty bomb-proof. My friend actually dropped one down a set of concrete stairs in a parking lot, and his is still going. And this pump has done over 2,000 samples. So it's a great pump. I like it, but buy what you want to do. Costs about $1,300 or so. So cool. What else do we have here? You're on the laptop. What are you up to?
I'm going to do data entry, so I'm going to record the filter date and the start time and the end time.
Perfect. Sounds good. So we're going to use the start time and the end times off the laptop because that's the satellite clock, so that's perfect. We also have to record one other thing, don't we? And that's filter volume.
Yes.
Perfect. So for that, we have a measuring cup. Now, I'm going to take that measuring cup over here. That's perfect, thank you. And that just allows us to pour what's filtered through here into the measuring cup so I can give you the volume you need. So your job as under data entry is to make sure I don't leave any blanks. If I do, you have to bark at me and say, Jared, I still need filter volume. The obvious quick efficient solution, which I tried, was to actually just mark these cylinders so they were graduated, and then I could read the volume straight off that. But I found when I did that, technicians were working with me, and I did it too, would forget to empty these between samples. And so by having it separate, and then what would happen is the pump would overflow, run into here, and kill my pump, because this is a dry pump. It's not supposed to have water in it. So I actually removed my gradations off, and now I use a measuring cup, which forces the technician to take this off, pour it into there. That way I know it's ready for the next sample. So that's kind of the cradle to grave workflow. Oh, Reagan, what do we have here?
This is our field fridge. So we brought it out in the field with us, and it has crushed ice in it, and it keeps our samples cold.
Perfect. Thank you. Let's take a look. What's inside there?
So an ice pack, but an ice pack alone really doesn't work because it doesn't get cold enough. So you want to make sure that your samples are also on crushed ice and in direct contact with the crushed ice. So you can see our samples.
Yeah, so I wouldn't even bother bringing the ice pack in the field because we know it's not appropriate, but we wanted to show people that it's not. So yeah, they have to be in direct contact with crushed ice at all time, and that's really key. That is an moment for sure. So anyway, so that's great. So let's get these samples out of the field fridge that we're going to filter today. We'll take actually the Greenburn Lake A and B, and then we'll get those going first, and there we go. We'll leave the field fridge closed tightly, and samples are nice and cool. So yeah, the other aspect I wanted to explain really quickly, and in addition to the pump, and we've got our water samples out from our field fridge, so that's great. I wanted to talk just a bit about my final step, which is removing the filter from the filter paper, which we're going to see in a moment when we do it together. But basically I have a pair of tweezers, or forceps if you want to sound technical, that enable me to remove the filter paper off the top of the filter mechanism here and to put it in a coin envelope. I have to be careful. My hands are going to be dirty all day. I'll be the one accessing the fridge. And so it's very important that you don't ever go into the fridge now. Your hands are clean, you're staying on the laptop, and you're staying on the labels. I'm just curious, maybe you can explain why you have a Ziploc bag under your labeling station.
Yeah, you bet. Just to make sure that there's no transfer of eDNA that might be on the table to the envelopes, because this is where our filter paper are going. It needs to be a clean and decontaminated surface. So we know this bag will do the trick for us.
Perfect. And just to let you know, we both washed our hands today. We did a good 3 happy birthdays wash with soap before we started. Less important for me because my hands are going to be instantly dirty. The second I touch this, my hands are now destroyed. They've got pond water from this pond, which is on the outside of the bottle, on my hands. So thus, I am not allowed to touch the envelopes. I am not allowed to touch the laptop. But Reagan, she's also done a 3 happy birthdays wash, and she has clean hands and is responsible for labeling the envelopes and working on the laptop. So we are avoiding eDNA transfer between the two of us. As much as we're sitting closely, we've got a genetic barrier. So that's great. Anything else you want to explain? What about the silica as a desiccant? We're going to get to use that.
These are in my station, so these really help the samples stay dry. So we're spending a lot of time making sure that our filter paper is dry. So these absorb any water that might be left over in the sample to make sure it doesn't leak through our coin envelopes.
That's perfect. So yeah, that also preserves, as I understand it, the filter so that it doesn't have water, because water is acting, it has exonucleases, bacteria and fungus from the site that we've collected, and those exonucleases, when they're in water, are working to degrade the DNA. So by using silica as a desiccant, we stop that degradation. So that's really important. There's another option. Do you remember hearing what that was for preservation?
Was it ethanol?
That was, and I moved away from using ethanol. And the reason is ethanol is a TDG prohibited substance, and so I can't ship it across the border. So if I'm using labs in the States, Michael Young or Goldberg, I have to ship samples to them. I can't get my samples across the border. And so you can, but it costs a lot and it's a bit procedurally heavy.
So
and
easier to stick with those?
Yeah, this is also the other thing about ethanol. It was Wimmis substance, molecular grade ethanol. It can cause blindness if you drink it. And so you've got another Wimmis item to worry about in your field kit. This is just plastic beads. So yeah, so that's why I like using the silica as a desiccant. The final step in the process, I noticed there's some Ziploc bags over there. So how many samples do you put in a Ziploc bag?
So we can put one sample site in each Ziploc bag. So each of the 3 field replicates that we took can go in one bag.
That's right. That's perfect. But we do need to make sure that if we're switching between sites, those get a different bag. Perfect. Sounds good. So to sum it all up, you're over there in your very clean station, you're labeling the envelopes and you're putting them in Ziploc bags, and then you're adding the silica desiccant to Ziploc bags, and you're going to be doing the data entry, and you'll be yelling out to me or talking out to me the start time and end time for filtration, and I'm going to record that with a Sharpie on here to keep track of it, and then when it's done, I will hand you a filter, you will open the coin envelope, I'll put that in, and we should be good to go. So
good.
That's perfect. If at any point anyone wants to enter your station, if I wanted to slide over there and type something because you were busy, is that allowed?
No.
So yeah, so we don't trade stations or replacement. So I noticed in your spreadsheet that you had a collected by, and you had the collector's initials, which I see you've put me down for. And on the filtration or filtered by, you've also put my initials down. And I think that's great, but what's that for?
We record who collected the samples and who filtered them because we want to make sure that everyone's following best practices and the steps appropriately.
That's
so
awesome.
if someone's consistently contaminating the samples, whether that be through field collection or the field lab, we'll catch that over time through recording that info.
That's perfect. And then we can help them do better.
Yeah, great.
Wonderful. Okay, well, I think that's kind of a good overview. So I think we're ready to start. I think it's always a good idea to go through what we're doing together and sort of make sure we communicate on what our respective roles are and what our responsibilities are so that we understand the process. So that was really nice to work through that with you, Reagan.
Yeah,
and I
thanks.
look forward to starting to filter. I guess the one thing I didn't explain here is this is bleach in the short vial here with the 2 forceps or tweezers in it. And this is distilled water and distilled water. I do a double rinse. And the reason I do that is I found when I was just doing a single rinse, after about 3 or 4 sites, this water started to get pretty bleachy just with the droplets from that. And so the double rinse just dilutes that again. The reason that's important, what happens if I have bleach on my forceps from my decontamination and I touch the filter?
It'll nuke the DNA.
That's right.
Okay, Jared, so once we have our filter papers in there, how do we do sample storage and when do we ship them?
But there's actually some neat papers on sample storage and the efficacy of different methods, and you can go through that in the course. But long story short, it's best to, once you've collected your samples, unless you're doing in-stream filtration, which I know you'll be discussing in the course, if you're doing the grab and go method, it's best to filter within 24 hours. And you also want to keep them cool in between collection and filtration for those exonuclease factors I talked about earlier. And so we want to slow the degradation. So we keep them in our field fridge, our cooler, with direct contact with crushed ice. And then we get back and we filter within 24 hours. Once they're through the filter, you put them in there, you add your desiccant, and they go into a Ziploc bag. At that point, they get put into either, you've got options. You can go room temperature, refrigerator, or freezer. But room temperature is the worst, refrigeration is second, and then freezer is best. And I'll let you explain that in the course with that lovely graph from the Hinlow paper that will show you. But basically, they can be stored in a freezer for several months before you send them to the lab. Like they're good for 6 months, a year. But ideally, I would just for safety, get them to the lab as soon as possible. And I'm not talking like 911, courier them down, but do courier them to the lab for safe transport and chain of custody and get them there within a couple of days or a week of filtration so that the lab can store them safely on a -40 freezer that's not self-defrosting so it doesn't cycle.
Yeah, we don't want someone to accidentally throw them out of our freezer.
Gosh, no. I made a silly mistake once. I checked out of my hotel and I drove all the way from Whistler to Vancouver before I realized they were in the freezer in the hotel. So another pro hack that I learned, I store my truck keys in the freezer with my samples. Now I can't leave. So yeah. So that almost cost us 30 grand. Fortunately, they hadn't cleared out my freezer. So yeah.
Sweet. Well, should we filter?
Yeah. Fun little pro hack stories for your teaching.
I love it.
There we go.
They're helpful.